So we were discussing about permutations in the earlier chapter. I have some more questions here with me. Question is, how many different number of two-digit number, how many different two-digit numbers can be formed with the digits 1, 2, 3, 4, 5, and 6. Remember, no repetition is allowed. So that is the question. We have to make two-digit numbers. Okay, so how many places are there? There are two places. How many options we have? Six options to fill the first place. Now, we cannot repeat the same digit that was used at the first place. So now how many options do we have? Five options, right? Yes. So they are dependent events because the choice here and here will decide what the number is going to become. So the answer is 30. Is there any doubt, anyone? Any doubt? So we have to calculate two different number of two-digit numbers. Okay. How many number of two digits? Two-digit different number, basically. How many number of two? अरे यार. Okay. How many number of two different digit numbers can we form? So there are two places to be filled. We have six options. Options should not be repeated. So six options for the filling the first digit, five options for the second one. And so we have 30 total number of ways. Why product? Because the event of filling the first place and the second place are dependent because they are deciding the number. That's why multiplication is there. Any doubt, anyone? No doubts?
No, sir.
Yes, let's now move ahead to the next question. Next question is, how many three-digit odd number can be formed from the given digits? They are 1, 2, 3, 4, 5, and 6 digits. Okay. Now the first case in which we have to tell where repetition is not allowed. Second case where repetition is allowed, basically. Okay. Repetition is allowed. Okay, so this is the question. We have to tell how many three-digit odd numbers are there. Now note this condition of odd. The number should be odd. Three-digit odd number can be from digit 1, 2, 3, 4, 5, 6. Okay, so there are three digits, three places. Let's solve for the first case where repetition is not allowed. We know it for very sure that the unit digit, what makes a number odd is its unit digit, right? 23 is an odd number. 45 is an odd number. 44 is an even number because of the unit place being odd or even. So here also, from the given choices, we need to make sure that we will fill only odd numbers here. So how many digits that are odd in the given options? 1, 3, and 5. We have three options to go with. Now that we should not repeat any of the digit. So after having used one digit, we are left with 5 choices to fill the second place, 4 choices to fill the other place. Now, please note one thing, that we will start with the place which is very special for us. Here, the place that is special for us is the unit digit. Okay, so all these events of filling the numbers are dependent on each other, filling the digits. So now 4 ways into 5 ways into 3 ways, that will make 60 the answer for this particular part. Any doubts, anyone? No doubts?
No, sir.
Great. So let's now discuss about the when we have to make a 3-digit number, 3-digit odd number out of the given 6 digits, and repetition is allowed. So condition is applicable here also. The first place will be filled with odd digit only, 1, 3, 5. So how many choices? 3 choices. How many choices for the second place? When we can repeat the digits. So how many digits we have now? All 6 digits. All 6 digits for this place also. Great. Dependent events, 6, 6, 36 into 3. Yes, 36 into 3. For 6 is 18 into 6, 108. Clear, everyone? Is this question clear? Now, in this chapter, there's no particular theory which is that much important, because if we talk about concept, it is very simple. It is just that the concept application is very volatile in nature when it comes to application. So that's why we will be focusing on solving questions. Okay. Cool. Is this question clear, everyone? Please reread the question and give yourself a minute to breathe also, and absorb whatever there is in the slide. Clear?
Yes, sir.
Next question says, this is very important question. It will make your understanding deeper for the concept. Fundamental counting. Given 5 flags of different colors, how many different signal can be generated by arranging at least 2 flags, at least 2 flags on a 2 flags in order on a vertical staff. Vertical staff. One below the other, or one above the other, basically. So this is what given to us. So let's solve the question. The given is that there are 5 flags of different colors. Means, let's say there's a red color flag, there is a green color flag, there is a blue color flag, There is a yellow color flag. There is a orange color flag. So this is like different colors flag are there. And there's a vertical staff, a pole on which you can, basically this is the pole on which we can arrange the flags, let's say, and we have to arrange at least two flags in an order. So red, green can be there to generate a particular signal. Okay, cool. So now we have to talk about all the contingencies, and we have to tell that how many different signals can be generated by using 5 flags. And this is a condition that we have to use at least 2 flags. So let's now first start with the condition where we are using 2 flags. Then we'll discuss about using 3 flags simultaneously, then 4 flags, then 5 flags. First, it's coming to the 2 flag scenario. If there are 2 flags, we have how many colors? 5 different colors. So if we have 5 different color of flags, so if there are like physical materials, that's limited. Okay, we have only one flag of a one color that is given to us, so we cannot repeat. Great. So if we have two, if we are using 2 flags, so there are 2 places, right, which can be filled. The first place can be filled with how many options? How many options do we have? How many options do we have? Flags of different colors. There are 5 flags of different color. There are 5 options. Having used one option earlier, now the second, for filling the second place, we have 4 options. And these are dependent on each other because this is making a whole flag. So they are dependent events. The total number of flags, total number of signals that can be generated by 2 flags is 5 into 4. That is 20. Talking about 3 flags. Talking about 3 flags. How many options? 5, 4, 3 options then. Because after using a color, we'll have only 4 flags left. After using 2 flags, we'll have only 3 flags left. So dependent events, 5 into 4 into 3 makes it 60. Similarly, 5, 4, 3, and 2. How many? 120. Using all the flags, 3, 4, and this is the 5. Okay. 120. So how many options for the first 5? 4 options, 4 flags, 3 flags, 2 flags are left. Only one flag is left. 5 into 4 into 3 into 1, that is 5 factorial, right? 120. Yes. So how many total number of signals? 20 plus 60 plus 120 plus 20. Why plus? Because they are independent events, different flags. That's why the plus. Now this becomes 80, 240. This makes it 320 the answer. So 320 signals can be generated. Clear everyone? Is there any doubt in understanding the question or the solution?
No, sir.
Yes. Please reread and try to understand why I have particularly like done or solved this question in a particular manner while multiplication, why addition. If you have any doubt, you may ask. Please read it again in 30 seconds. Clear everyone?
Yes, sir.
No doubts. Really? Okay, fine if no doubts. So where is the S generator question? This is the question. How many five, how many different 5-digit telephone numbers can be constructed using the digits 0 to 9? Okay, now the condition starts. If each number starts with 67, okay, 5-digit number is there, and each number is starting with 67 digit, 67, for example, 61125, and no digit shall appear more than once. So repetition is not allowed. We have all the digits from 0 to 9. They are basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. How many digit number? 1, 2, 3, 4, 5. So we'll have only one choice with for the first digit, for the first place. Why? Because the number should start with 67. So there is only one choice for both. Okay. So having spent two choices earlier, out of how many choices are there? 10. Like in total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 1 to 9 is 9 plus 0, that's 10th choice. So we have 10 choices. We cannot repeat any choice. Two choices have been utilized. So how many choices are left now here? 8 choices. Having used 3 choices out of 10, 7 choices are left. Having used 4 choices out of 10, 6 choices are left. They are dependent event because they themselves are going to in collection are going to decide the number, what the number is going to be. That's why they are dependent events. So multiplication, so the total number of numbers that can be formed is 1 into 1 into 8 into 7 into 6. So 42 into 8, 6, 336. 336 numbers can be generated. We are using these conditions. Is there any doubt, anyone?
No, sir.
Great. Please absorb the material that is there on the slide. Any doubts?
No, sir.
Now let's discuss one more question. How many numbers are there between 100 and 1000? Between 100 and 1000, not 100 and 1000 are not included here. Which have exactly one of their digits as. So first let's understand the parent question that is there. How many numbers are there between, so numbers starting from 101, 22222, before 1000, that is 999. So all three digits number that we are talking about, except 100. Okay, 100 is also a 3-digit number. 1000 is a 4-digit number. Okay, so when 7 is placed at the unit place, so three digit number, and 7 is placed at the unit place. How many choice? One choice. Okay. When we are discussing about numbers and it's not given the condition for repetition or not, repetition is not given. So we assume that we are allowed to repeat the digits because we are discussing about numbers. Great. So how many choices do we have to fill the second place? If we have, how many digits we have from 0 to 9? There are 10 choices, right? 10 choices. We may use any. We have fulfilled the condition that it should be 7-digit number. Okay, so 10 digits, 10 choices. Now, what about the 100th place? Now, there is an exception. We cannot use all the choices here. We cannot use 0. Why not 0? Because using 0 will make the number 2-digit number less than 100. Okay, that's why we will not be able to use 0 this time. So how many choices do we have to fill the third place? 9 only. Now this point is very important for you to understand. Is there any doubt?
No, sir.
No doubt. Yeah. So 9 into 10 into 1, that is 90 such numbers are there between 100 and 1000 which have exactly one of their digits as when 7 is placed at the unit place, right? When 7 is placed at the unit place. There are 90 such numbers. Now it's a thing to discuss, to think about. Let's write 100, 101. So 107, 110. Then 100 and okay. Then 117 and 120. And like this, we will if we will keep on repeating this, 7 is coming after in every 100, like from 100 to 200, it will go on like this. And at one point of time, it will become 191, 197, going till 200. So how many sevens? One, like 10 sevens are there. From 100 to 200. From 200 to, so this is for 100 to 200. For 200 to 300, there will be another 10 into 7, that is 70. For 300 to 400, there will be another 70. How many are there? 7, 1, 2, 10. So basically 10 into 7, no. Only 10 are there. Sorry, only 10 are there. Not 70 exactly. 7 on unit place, which we are discussing about. 10 and 10 and 10. For 400 to 500, another 10 sevens at the unit place. 500 to 600 numbers, there will be another 10. For so basically 600 to 700, another 10. For 700 to 800, another 10. For 800 to 900, another 10. And from 900,000, there will be another 10, having 7 at their unit place. So how many total? 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear everyone? So 10 into 9 becomes 90. This is another place we could have also calculated it manually. Clear everyone?
Yes, sir.
Yes. 90 is the answer. Okay. Now let's the question has more to ask from us. In the next part of the question, we're asked with different condition. Oh, basically I should do one thing. And better. Now in the second part of the question, when 7 is placed at 10th place, okay, such number of we have to find out such number, such numbers, such numbers number. Okay, so we have a 3-digit number from 101, sorry, 101 to 999. Both are included here. So we are discussing basically about 3-digit numbers, and 7 should be at the 10th place. So one choice for filling this, we had 10 choices. Okay, 10 choices. 10 choices to fill the 10 unit place, and only 9 choices to fill the 100th place, because 0 is excluded while fulfilling this, because अगर हम 0 consider करेंगे on the 100th place, if we will consider 0 on the 100th place, then it will make our number a 2-digit number, but the condition is given that the number should be between 100 and 1000, and we have analyzed that only 3-digit number that we are talking about except 100. So 9 into 1 into 10, that becomes 90. Okay. So there are 90 such numbers which are there between 100 and thousands, having 7 at the 10th place. Is that clear, everyone?
Yes, sir.
Yes.
Yes, sir.
There's another part in which it is asked when 7 is at 100th place. Now this time things will change. 7. So one choice for filling this. How many choices for filling the other 2 places? 10 choices. 10 choices. So 1 into 10 into 10, 100 such numbers are there, having 7 as their unit place. So basically from 700 to 799, these are the 100 numbers having 7 at the 100th place. Clear? Crystal clear, everyone?
Yes, sir.
Yes. Great. Now we have already discussed about the formula. Let me rewrite it. That's a basically formula. Clear? Now there is a question on this formula. We have to find the value of n. Given that n p4 to the is 2 and minus 1 p3 is 9 is to 1. That is the given condition. That's the given information. Okay, so np4 is to n minus 1 p3 is given as 9 by 1. Let's write their formula n factorial divided by n minus of 4 factorial. This is what? N minus 1 factorial divided by n minus r, that is n minus of 1 minus of 3 factorial. That is given as 9 by 1. If we like simplify it, it becomes n minus 4 factorial, right? It's equivalent of writing n minus 4 factorial, and this cancels each other. What is left there on the left hand side? N factorial divided by n minus of 1, n minus of 1 factorial is given as 9. Okay, So n factorial can be expanded as n into n minus 1 into n minus 2 into n minus blah 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 till 1. So we can say that n into n minus 1's factorial. Yes, right. So similarly, in the question below, in the solution here, n factorial can be written as n into n minus of 1's factorial divided by n minus of 1 factorial. Wow. This cancels this. What is left is n is equals to 9. That becomes our answer. Is that clear, everyone?
Yes, sir.
Great, great. The ratio is given to us. We have found the solution. This was the question, right? There's another part to the question where it is given that five permutation R is equal to twice of 6p R minus 1. Similarly, we'll apply the formula. There are there is only one variable in the equation, that is R. So we'll solve it. 5 factorial divided by 5 minus R factorial equal to 2 into 6 factorial upon 6 minus R minus becomes plus factorial. Okay, 6 factorial can be written as 6 into 5 factorial, right? According to our previous conclusion. Okay, where this factorial is there on the n minus 1 only. Okay. So 5 factorial 6 cancels 6 factorial by 6. This becomes 6 plus 1, 7 minus R factorial. Okay, let's take this 7 minus R factorial, cross multiply it. 7 minus R factorial divided by 5 minus R factorial. 2 into 6 becomes 12. Great. Now let's solve it here. Okay, 7 minus R factorial can be expanded to 7 minus R minus 1. So 7 minus 1 becomes 6 minus R. 5 minus R. Let's stop here. Divided by 5 minus R factorial equals to 12. This cancels each other. And what is left is 7 minus R into 6 minus of R. Now, instead of solving the quadratic equation, let's be smart, right? We know, so the difference between the two factors here is of 1. So let's find out two factors of 12 having difference of 1. That is 3 and 4. Okay. So, which should be the larger one? This, so 7 minus R should be 4. 6 minus R should be 3. So 7 minus R, if it becomes equals to 4, then R becomes 3. If 6 minus R becomes equals to 3, then R becomes 3. Okay, great. So we have finded out the value of R here. Great. That is what we require to do. So R is equals to 3 is the answer. Is there any doubt, anyone? Any doubt?
No, sir.
Okay. So now I'm going to write some important relations. N P of n is N P of n minus 1 only. We are going to discuss them in detail. That's equivalent of writing. Like basically, we are arranging n elements out of n elements at n places. That's n factorial. N P n is twice of n P n minus 2. Okay. N P of R can be written as n into n minus 1 P R minus 1. fourth property is n p of r is equivalent to n minus of r plus 1 into n p r minus 1. Okay. Fifth one is n p r equivalent to n minus 1 p r plus r into n minus 1 p r minus 1. I didn't learn them during my preparation. Okay. Neither you are required to do so. Just understand why they are happening, like why it is so. So discussing them one by one. Okay. So let's discuss them why it is so. Starting with the first. Start with the first property then. N factorial upon n minus n factorial is, so we are taking left hand side and the right hand side, and the third hand side. Okay. So n minus n is basically 0. 0 factorial is 1. That becomes n factorial. N minus n is 0. 1 factorial is 1. That becomes n factorial and factorial. That is why it is 2. Simply. Clear everyone? Any doubt? We have solved them using the formula, and we are just discussing about the formula, na application of formula in different cases. Clear?
Yes, sir.
Yes. Let's now discuss the second one. Okay. And Pn is n factorial, we have discussed earlier. 2 into n factorial upon n minus of n plus of 2 factorial. Okay, that becomes 2 into n factorial. N minus n cancels. 2 factorial is 2. 2 cancels. N factorial is equals to n. Simple. Clear everyone? Is this clear everyone?
Yes, sir.
Okay, let's now discuss the third. NPR is n factorial upon n minus of r factorial. Given is n into n minus 1 factorial upon n minus 1 into minus of r plus of 1 factorial. Now, please don't forget to multiply the whole to the minus sign. So plus r becomes minus r, minus 1 into minus becomes plus 1. Clear? Minus 1 cancels plus 1. So that becomes n into n minus 1 factorial. What is n into n minus 1 factorial? Can you remember? N into n factorial can be written as n factorial, can be written as n into n minus 1 factorial. So can it be written back also? Yes. So this particular numerator becomes n factorial divided by n minus r factorial, which is equivalent to the left hand side. That's how the property is staying true. That's a proof. Clear everyone?
Yes, sir.
Let's now discuss the fourth property. Left hand side, basic formula is equals to n minus of r plus 1 into n factorial divided by n minus of r plus 1 factorial. Okay. So let's expand the n minus r plus 1 into n factorial. Let's now expand. Let's write the left hand side also. Let's now expand the denominator factorial. So n minus of r plus 1 into n minus of r plus 1 minus 1 cancels, and minus r factorial. This and this cancels. Now the left hand side is equal to right hand side. Yes, your mic is on mute, Yareni. Please sing after muting yourself.
Sorry for
Okay.
the inconvenience, sir.
Alright, no problem.
No,
But
when
just
I do sums, if I'm frustrated, I used to do it. That's why.
okay. Sometimes it happens with all of us. Okay. No need to feel awkward or something. Okay, got it. Fifth property. The left hand side n factorial divided by n minus of r factorial equals to n minus 1 PR. So n minus 1 factorial divided by n minus 1 minus of r factorial plus r into n minus 1 factorial divided by n minus 1 minus of r plus of 1 factorial. Okay, let's now solve it. So x n factorial n minus r factorial. Now this is first let's solve this one. Minus 1 plus 1 cancels. Okay. So n minus 1 factorial divided by n minus of 1 minus r factorial plus r to n minus 1 factorial divided by n minus r factorial. So that has become n minus of r factorial. So let's now expand it because we are able to see something here. N minus of r at minus of r minus of 1 factorial. So if we observe this particular term, n minus 1 factorial is common in the numerator and n minus of r minus of 1 factorial is common in the denominator part. So let's take it common, right? Let's go ahead then. Taking common n minus 1 factorial divided by n minus of r minus of 1 factorial. 1 plus what is left r upon n minus of r. Okay, n minus 1 factorial divided by n minus r minus 1 factorial. Now taking LCM n minus of r. ऊपर क्या होगा n minus r plus r cancels r, so that is become n. Great. N into n minus 1 factorial can be written as n factorial. N minus r into n minus r minus 1 factorial can be written as n minus of r factorial. Has become to the equal to the left hand side. So LHS equals to RHS. That's why this property is true. Clear, everyone? Yes. Is that clear? Any doubts?
No, sir.
Yeah. So let's conclude our class. Thank you, everyone. Jai Hind for your.
Thank you, sir.
Yes.
Thank you, sir.